All right, this is 911 Part B. We're going to continue to use identities to manipulate an expression or equations. Remember, these are the identities we need to memorize. We need to memorize them. We have reciprocal quotient and, more importantly, these newer, we've never seen before Pythagorean identities. They got to be memorized. Now, our thought process, first thing is we look for those larger identities, the Pythagorean, sum and difference, double angle, etc. Then we use some algebra. Okay, add or subtract, distribute, conjugate, factor, things like that. And then we're going to change the sines and cosines and repeat. So for this one here, we're going to go ahead and do the right side because it's a little more complicated. There are no Pythagorean identities, right? No sine squareds or anything like that. And then it does look like I can add these together, or subtract these, but I need to find the common denominator. So 1 minus sine theta, top and bottom. And then 1 plus sine theta, top and bottom. So rewriting that, so now from here, we're still in kind of like, I see some algebra, like, right? I can distribute this. I can distribute this. So I get 3 plus 3 sine theta minus 3 plus 3 sine theta. And on the bottom, I'm going to get 1 times 1, 1 times sine, negative sine times 1, negative sine times times sine. So that's going to reduce, that's going to reduce. Well, I have my 6. Look, we can look at that and compare that. But now, starting back at the top, I see a Pythagorean identity. So it's sine squared theta plus cosine squared theta. That equals 1. So how do I get this 1 minus sine squared? So I can subtract sine squared on both sides. So I know that cosine squared is 1 minus sine squared. So I can, so that's cosine squared. And now if I imagine this broken up, right, that's cosine times cosine. That's what cosine squared is. So I have my 6. I just broke that up like that. So now I have sine over cosine. That gives me my tangent theta. And then 1 over cosine gives me my secant theta. For this one here, there's nothing obvious about it. First, Pythagorean, no algebra. Everything's already sines and cosines. And the reason is, it's going back to the previous lesson, we talked a little bit about those weird conjugate pairs. Well, whenever you see like some weird conjugate stuff going on, it means you're going to have to multiply by the conjugate. So I'm going to multiply the top and bottom by its conjugate. I'm just going to do the right side. You could do the left side if you want. It doesn't really matter. But whenever you see like conjugate type stuff, it probably means you're going to have to multiply by. So distributing 1 times 1 minus cosine plus cosine minus cosine squared. Those are going to cancel out. So I have 1 minus cosine squared theta. Again, that's a Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. So how do I get 1 minus cosine squared on the same side? So I'm going to subtract that. So I know that sine squared theta equals 1 minus cosine squared theta. And so that I'm going to substitute in. And now I know the sines are going to cancel out. There you go. Now they're the same. For this one here, I can change that to 1 over cosine. No Pythagorean, no algebra, change everything to sines and cosines. Those cancel out, so we get 1. For this one here, I know we could either do the left or the right. The right side is probably a little bit easier, and the main reason is we see the sine squared and we're thinking to ourselves, okay, that might be a Pythagorean identity. So if I replace that with 1 minus cosine squared, now I've broken it up into 2 things, whereas this is just 1. So then it's like, okay, maybe that's not what I want to do. So maybe let's try the other side. So this would be 1 over sine theta, and then this would be cosine over sine theta. And so then these multiplying across. You get that. So what did we learn today? We talked more about identities. This does conclude our lesson. If you have any other questions, please leave them in the comments.